the rinsing the fuel cell it out, it's become automatic, and therefore you don't have any servicing in the areas of cleaning up the resin cavity. Matter of fact, the release of the gas inside the resin cavity acts as a scrubbing action, so it never clogs up, no matter how much contaminants, or if you have like 40 parts or 50 parts per million, it won't clog up the system at all.
Well, stand another use for the whole system is just purifying water.
Yes.
You can just use it to purify water and get heat as well.
Yes, and not only that, it also gives us the ability to move into other areas of the technology. Yeah. Next factor we did is also the Lord was dealing with me is developing what's called the electron extraction circuit. And this electron extraction circuit was very unique in several areas. We already found out now we can release the hydrogen from water, and its burn yield was 2.5 times that of gasoline. That's National Bureau of Figure standards. That's the NASA's figures, and that's our figures to show a tremendous amount of release of energy. Now, we were going for that we needed to protect the military integrity of the United States and of the Western world. As I was making preliminary presentations to General Bashard and their technical staff at Wright-Patterson Air Force Base, I said, General, I don't care how sophisticated hydrogen or powered aircraft you have sitting on the runway, without any diesel, without any aviation fuel, it becomes a piece of junk. Now, generals don't like to be told that their equipment is a piece of junk, but it becomes so when you have no form of energy. So it was imperative that we now start to go in areas of developing systems that we could literally maintain the military posture of the United States and the Western world. And of course, I've been in very high-level meetings in England and other countries demonstrating or presenting the technology. Now, as we started to, we found a way of releasing the energy from water very economically. It solved the KISS method and the law of economics. Now we started to go into resonance, as we started pouring out in resonance, hitting the fuel cell in a way that we're now allowing the hydrogen gas to be developed even at a higher rate of production. And we've taken it now and raised the voltage up to the point that we're starting to ionize the water, the atoms of the water molecules. Now, ionization is where voltage is much like that of your neon tube. When you apply voltage across it, it plucks off the electrons. And so we're plucking off the electrons now of the atoms of the water molecules, and then those atoms have missing electrons will take on a positive electrical charge. And now you've got some negative charge electrons bouncing around in there, and we're now starting to superimpose a physical impact onto the electrical polarization process, which now gives us a phenomenal high gas yield over the prior state of the art. Now, since we're going into the ionization process and we are now plucking off the electrons of the atoms of the water molecule, and these electrons are now being injected out of the water molecule atoms, now we're liberating these electrons. We're liberating them. And as a result of this, we're now starting to pull the electrons out of the water. And as we pull them out of water, if I now put a P plus on this side, and I have a light bulb here, and I start plucking the electrons, and they're moving along the wire here, down here, and as they go into the filament, they interact with the filament, consuming the electron, and in the process of consuming it, produce heat energy in the form of light energy. Does that violate any laws of physics? Therefore, I am now producing electrical energy as a byproduct of the process. Isn't that phenomenal? Gee whiz.
So you got some stray electrons coming off of the system that you can utilize for heat production.
Right. So I'm pulling off electrons. I want to destabilize now. Okay, now I got an economical way because all I have to do is up the voltage. If I increase voltage, I increase hydrogen gas yield, right? So I've now solved the second problem in NASA, being able to produce the gas in demand. But I need even higher energy yields in order to be able to get it into the aviation industry, to get it in to protect the military integrity of the countries. So the key was that I wanted to also produce electrical energy. So by pulling off the electrons out of the water, and as I pull the electrons out of the water, I am now producing electrical energy, am I not? Electricity? Yeah. Mm-hmm. Now, under Coulomb's law says in an electronic circuit, if you had 1 volt deflection in an electronic circuit, what will happen? You roughly come up with 6.25 times 10 to the 18th power of electrons, which is equivalent to 1 amp.
I'm glad you said so.
Right? Yeah. So theoretically then, if I use water as the source of the electrons, right? If I would apply 100 volts across that light bulb, theoretically speaking, how much amps would I be able to pull out of the system?
100 tons.
Well, it'd be 100 amps, right? So at 100 amps, 100 volts times 100 amps gives me what? 10 kilowatts of electrical energy.
Hell of a lot.
Isn't that amazing?
So you just need to produce your gas. You don't even need an alternator to get your electrical energy.
Right. I don't need any mechanical rotating device whatsoever.
What happens to the gas that has the electrons pulled off when they're recombined? What happens to how do the electrons get back on the gas? Back to form the water.
Okay. You can come up here, and the gases can come up here to a ground sink that can take electrons back in from the ground, right? And the law of physics is if I got an oxygen atom here that's got 3 missing electrons, all right. Therefore, I can
suck it up.
I can suck it off from the ground of Earth to bring it back to stabilize. But I really don't want to stabilize it. Okay, but I'm using water now as the energy source. Just like you look at gasoline as an energy source, now you're looking at water as an energy source. So as a result of this, you now can look at natural water both as a gas source and also as an electrical source. You see what I mean? Okay, and hydrogen. Now, if I'm producing electrical energy, could I not take this back through the voltage intensifier circuit, the DIC circuit, take it back here, restrict the amps, allow voltage, take over, and produce more gas? So I now have a self-sustained oscillation system that just as when you fire it up and you prime the system, it goes until what condition? Until there's no more water in the cell. Okay. Now the Earth is covered by three-quarters of the Earth is covered by water, so I'm not going to be worrying about running out of fuel source.
But you won't anyway, because you recombine the gas back to water, and you got the water back again.
Yes.
You got all of it totally renewable.
Yes.
Do you get all of it back in this process? You get all of it back.
Yes. I need to power the aircraft. I need to get the aircraft carriers going. We need to be able to sustain aviation industry, and we need to be able to have energy to maintain the industrial plants. If we can't have a sufficient amount of heat or energy quickly to maintain the steel mills will not come in. So it was imperative that I would develop the technology in all areas of the economy. In other words, what good would it be to develop technology, put it as a home heating system, or put it in your car and I can't get it to the trucks? If I can't get it to industry, I was pulled in a closed-door meeting in Columbus, Ohio, when the Columbia gas system informed the industrial leaders of Ohio that their gas was being cut off. Well, I saw some of the richest, most powerful industrial leaders of the state popping pills and thought they're going to have heart attacks. Because what Columbia gas system told us was that without fuel, go home and tell your 2,000 or 3,000 employees to close the doors because you had no energy to make a product. And if you can't make a product, you can't pay your bills, right? And if you can't pay your bills, you're hurting because the bigger you are, the faster you're going to fall.